Today we're going to describe more than one event. And you're saying, I'm sorry, what? Well, we're going to talk about probability. So more than one event with probability. Here we go. All right, so probability, remember, can be described as a lot of ways, but the basic definition is the number of desired outcomes. So what do you want to have happen divided by the total number of outcomes. So you're looking at the proportion, right, of what you want to have happen over the total possible. So we have three things we're going to talk about today. Or, so this or that, and this and that, or not, simply not that. Now, how do we note that? Because we're going to do today using symbols. So when we're talking about or, you're going to see it kind of as a U. So if we say, what is the probability of event A or B? So it's got that U type symbol. When we get to and, the and symbol looks like an A without the line through it. So if you think about, I want the probability of the event A and B, then we have, see how it's kind of looks like an A? That's how I remember. Now, when we use not, it's more of like a little marker here. So we call that prime. So like the probability of A prime. This means not A. Okay, so that's the notation. So now let's get into some things. We have a stack of 4 blue cards and 3 red cards, and they're numbered. So the blue cards are numbered B1, B2, B3, and B4, and the red cards are numbered R1, R2, and R3. Now, for notation, B means blue, R is red, E means an even number, and O means an odd number. So we're going to do 3 probabilities with these 2 stacks of cards. First, we're going to find the probability of B and O. Notice how that symbol looks like an A without that line through the middle. So B and O means we want the probability of blue cards and odd, right? Because B stands for blue and O stands for odd. So how many cards? Remember, probability is the desired, what we want over the total. Well, we have 7 total cards. So our denominator will be 7. But blue and odd. How many blue cards are also odd numbers? Well, that would be B1 and B3. So there's 2. So our probability would be 2 over 7. Great. Let's look at the next one. The probability of R or E. So we're looking at red or even. Now this one's a little bit trickier. We still have 7 total options. So our denominator is 7. We know we have 3 red cards. So that's where we start. We know we have 3 of these, but it says or even, which means we can have blue even cards, and that would be okay. And that would be B2 and B4. So there are 2 of them. So 3 red cards plus 2 blue even cards gives me 5 total desired outcomes. So my probability is 5/7. In the last one, it says the probability of O prime. This means not odd. Okay, so because it's not odd, well, if you think about it in this case, not odd means even. But let's think about this. If we know the probability of odd, well, again, denominator of 7, I have B1, B3, R1, and R3. Those are all odd numbers. So the probability of odd is 4 out of 7. So the probability of not odd is all the rest. So if 4 of them are odd, then 3 of them are not odd. So that's the idea of the not, is everything that it isn't. All right, let's do one more example. In a class of 20 students, these children were asked to wear either a red, green, or blue shirt. See the organized results in the following table. So you'll notice across the top, we have our blue, green, and red shirts. And then across the left side, we divvied up these students into 2 groups, those that are wearing glasses and those that are not wearing glasses. So you can see we have this table noted. Okay, so now we're going to do 3 probabilities given a table. So kind of a different way to look at it. In letter A, we want the probability of B, that's blue, and glasses. So this is blue and wearing glasses. Well, if we look, okay, so glasses is this top line, and blue is the first column. So how many students are wearing a blue shirt and glasses? Just 3. Okay, so 3 is my desired, and we know we have 20 students. So our probability is 3 out of 20. Okay, the next one, probability of red or no glasses. Now this one can be a little bit trickier, but if we have a table, this is what I like to do. Here's my red, here's my no glasses. And then I just add up all of those numbers. So it's kind of like in a reverse L. I've got 7 plus 1 plus 4 plus 1. Those are all of my students that are either red or no glasses. So that's 8 plus 4 plus 1. That's 13 over 20. Okay, and I'm sorry that my table is a little bit messy now. In letter C, we have the probability of not green. Okay, so first, let's do what we did in the last one. Let's find the probability of green. Well, I have 5 total students wearing a green shirt. That's 5 out of 20. So my probability of not green is everyone else. So if 5 students are wearing green, that means 15 students are not wearing green. And we should always reduce fractions, and 15 over 20 reduces to 3/4. So the probability of not green is 3/4. And that's how we can use a table, or before we were using cards. So some different ways to think about probability and describing more than one event.